Hello there. With 1.5 equations, we're going to start off with just a basic introduction to what an equation is. So an equation is an algebraic expression containing an equal sign. An algebraic expression containing an equal sign. So we know what algebraic expressions are using numbers and symbols. An equation just has an equal sign. We're going to look at some basic ways of solving equations. There's going to be a lot more of it to come in Chapter 2, but for now we just have a couple basic ways. And first, a couple terminology things. A set. We're going to talk about sets and elements. A set is a collection of objects or numbers, usually indicated with curly braces. We use curly braces to tell us that we're using a set. And an element is one number or object in a particular set. So a set contains elements, those elements being the numbers inside that set. So we are first going to use a replacement set to find a solution set for an equation. A replacement set is a set of values that we will use to replace the variable in our equation. To find a solution set being that set of elements from the replacement set that are solutions to our equation. So when it asks us to find the solution set of the equation 2q plus 5 equals 13, if the replacement set is 2, 3, 4, 5, and 6. Now, when we use a replacement set, we must set up a table. We must set up a table with our replacement set along one column. We're going to work out what if it. We're going to put that value into the equation and then indicate if it's true or false. So we're going to solve the equation 2q plus 5 equals 13 if the replacement set is 2, 3, 4, 5, and 6. So we're going to take our first value for q, plug it in, 2 times 2 plus 5 equals 13. Let's see, then we get 4 plus 5. Does that equal 13? No, 4 plus 5 is 9, not 13. That does not equal 13. So this is false. We take 3. 2 times 3 plus 5 equals 13. We look at 6 plus 5 equals 13. Does 6 plus 5 equal 13? No, 6 plus 5 is 11. That is also false. We look at 4. 2 times 4 plus 5 equals 13. 2 plus 4, we get 8 plus 5. Does that equal 13? That does. That is true. We look at 5. 2, 5 plus 5 equals 13. Does 10 plus 5? No, that doesn't equal 13. Let's look at 6. "12 plus 5 also does not equal 13. That is false. So our solution set is that Q is equal to, we're talking about solution set, so it needs to be in braces. Q is equal to the set 4, the element 4 in the solution set. So we have found solving using a solution set. Now, let's talk about solving using the order of operations. Sometimes our equations are going to look just like this. It looks like an expression that we would use the order of operations on, but now we have an equation. So we're going to solve just like we would using the order of operations. So if we have t equals 9 squared divided by the group 5 minus 2, let's see, what are we going to start with? We have g, e, m, d, a, s. We're going to start with our group. So we're going to have t equals 9 squared divided by, let's see, 5 minus 2. 5 minus 2 gives us 3. Now, if we have 9 squared divided by 3, GE, next is going to come our exponent, so we're going to have t equals 9 squared, which becomes 81 divided by 3. Now we have what's left, t equals 81 divided by 3. We are left with t equals 27. and we have used order of operations to solve an equation. All right, now a couple more examples using order of operations. I know some of you may already feel like you know how to solve equations using other methods. Sometimes it might involve moving things from one side to the equal sign to the other. For now, we're not going to do that. We're going to keep things on the same side of the equal sign, because technically we don't know how to move things to the other side of the equal sign just quite yet. Bear with me. So if we are solving with n times the group 3 plus 2 plus 6 equals 5n plus the group 10 minus 3, we're going to start, again, order of operations. We're going to start with what's in a group. So we have n times the group 3 plus 2, which, as I just gave it away, is 5 plus 6 equals 5n plus... we can do this group at the same time as we did the other group. It's all in one group and they're all one step, luckily. So if we take 10 minus 3, that's going to leave us plus 7. So now if we look, we have 5n plus 6 equals 5n plus 7. Let's do a little bit of critical thinking here. What, again, because we can't move things from one side of the equal sign to the other, what can we plug in to n that if we multiply it by 5 and add 6 is going to equal to taking that same number, multiplying it by 5 and adding 7? So, if you think about it, there's nothing. We can't take any value and plug it in because we start with 5n, but this side is always going to have one more. So our answer would be that there is no solution. There is no solution because if we think about it, this side is always going to have one more. There is no constant value for n that we can plug in that would give us a true equation where one thing truly equals another. All right, let's look at this example here. 12 times the group 10 minus 7 plus 9g equals g times the group 2 squared plus 5 plus 36. All right, so let's look at some things that happen inside our groups first. We have 12 times 10 minus 7 is 3 plus 9g equals g times, inside this group, 2 squared, that's 4, plus 5, plus 36. We still have a group over here, so we still have 12 times 3, plus 9g, equals, let's see, g times the group, 4 plus 5, so that's going to be g times 9, plus 36. Let's see, let's do this multiplication. We have 36, 12 times 3 is 36, plus 9g, equals 9g plus 36. With a little rearranging, we see that 9g plus 36 equals 9g plus 36. Again, because we can't move things from one side of the equal sign to the other. Now let's think about it. What can we plug in for g that if we take 9 times that and add 36, it equals 9 times that same number plus 36? If you think about it, we can plug in anything for g. So if we can plug in any real number, we're going to say that the solution is all real numbers. We're going to say the solution is all real numbers. This is what's called an identity. If the solution would give you all real numbers, it's what's known as an identity. The equation is true for every value of the variable. Now, let's take a look at our practice problems. We're going to be looking at page 172, 11 through 31 odds. So this first part asks us to find the solution set of each equation if the replacement sets are as they are stated there. So I want to see, since we're doing odds, we have 4. I need to see 4 tables. If you want credit for this homework, you're going to show me 4 tables in your work. If there aren't 4 tables, you're not getting full credit, and I can bet you on that, all right? Now, there is one quick correction that I need to make. 23, at least in my book, is missing an operation down here, so we need to know that it is 9 times 6 plus over the group 8 plus 1 times 3. All right? Have fun.